everyone. Welcome back to the second half of the Capital Markets Day. James Michael from Berenberg's Energy and Environment Research Team, and on the panel, I'm happy to have, obviously, we know Graeme, CEO of Ilika, Julian Hetherington from the UK's Advanced Propulsion Centre, and Thomas Bartlett from the Faraday Battery Challenge. I think obviously most of you know Graeme, but maybe it might be worth just putting a bit of context around Julian and Thomas. Maybe quick intro, who you are and what your organisations do might be helpful for the audience.
Sure, yeah. So I'm Julian Hetherington. I'm Automotive Transformation Director at an organisation called the Advanced Propulsion Centre. We've been around as an organisation since 2013, set up out of a joint initiative between government and the UK's Automotive Council to run a programme of research and development funding in the kind of mid to late stage technology readiness level, so helping get things towards industrialisation readiness. We've deployed about £1.5 billion of funding over the last 10 years. And then in 2020, we were asked by government to be the front door and deploy the up to £1 billion Automotive Transformation Fund, which was largely focused on capital investments in establishing manufacturing capacity. So very the large battery factories that you've seen in the press have been as a result of the funding that we've deployed on government's behalf. My own background actually is automotive for actually nearly 35 years now. Initially with Ford and then with Jaguar Land Rover, where I was responsible for a variety of programs over my life, and most recently responsible for globalization programs, so dealing with major capital projects in overseas locations. So that's my background.
That's great. Hi everyone, I'm Thomas Bartlett, so I'm Deputy Challenge Director for the Faraday Battery Challenge, which is a £610 million government initiative to help grow a UK battery supply chain. So we fit sort of just before Advanced Propulsion Centre. If you're looking in terms of technology development, we support everything from early stage research through something that we set up called the Faraday Institution, which is investing about £200 million into, I'd say, world leading research. We've got about 500 researchers, 27 universities, generating really good research focused on answering industry problems, and I think that's the key bit for that. But also supporting business innovation, companies like Ilika who've accessed our programs to get sort of R&D funding to support obviously their journey towards market, but also holistic as well. We cover everything from skills programs where we're developing manufacturing skills centres, doing international engagement, trying to get companies out into markets, and lots of other things as well, also around some engagement with investors as well. We also invest quite heavily in capital as well. So one of the things that we've done is invest in the UK Battery Industrialisation Centre, which is it's now north of £200 million investment into gigafactory scale equipment, and basically a gigafactory that is open access for UK PLC. Because when you're looking at, I'm sure you would cover points today that when you're developing batteries, the capital needed to put the equipment in is expensive. We're trying to de-risk that for UK industry, and we've got, let's say, through that facility something that is world leading and about 3 years ahead of its closest competition in terms of the scale it can operate, the equipment that's there, and also its readiness to support businesses in the UK. So as I say, that's sort of where I am. My personal background is I'm a doctor of electrochemistry, worked in a few companies developing battery materials, and also in solid state battery programs for companies. Not Ilika, just a.
Not yet, Tom.
So for a few years before joining government.
All right. Thank you for that. I guess probably guessed from the intros that we're focusing on Goliath here, and I guess we'll dive straight into the first question on EV and the EV markets. And I guess it's been bit of press coverage recently around slowing sales in that space, and I think broadly speaking coming into the year the expectation was that growth in EV sales was going to slow through 2024. So maybe just helpful to get a bit of context around whether you think that's a short-term blip or a long-term trend. How concerned should we be? Maybe Julian.
Yeah, it's a very interesting position to be in, actually, because we've seen, certainly in the first phases of EV adoptions, the technology for conventional lithium-ion cells has started to play out and become more commercially ready. with larger established battery companies, including those supplying the likes of Nissan, for example, and Volkswagen. Sales actually kind of rose quite rapidly, helped by incentives around Europe and in the UK. In the UK, focused around plug-in car grant, which disappeared a couple of years ago, and also around company car tax incentives, which still apply today. Benefit in kind taxation for quite a significant part of the UK market really helped drive the early adoption of certain types of vehicle. And we see a similar sort of picture unfolding around the EU 27 as well. If you look over the last couple of years, we've seen EV penetration in the UK market for passenger cars get to about 16 or 17%. And it might not have escaped your attention that this year is the first year that the zero emission vehicles mandate bites, with a target of 22% of the market for passenger cars being zero emission vehicles. That really means battery electric vehicles. You can also do this with fuel cell vehicles, but there are very few of those on the market. So that's a bit of a gap to close. Next year, of course, that starts to step up again. You've got to get to 28%, and then it starts to ratchet up until you get to 2030, when 80% of the new passenger cars sold in the UK must be zero emission. That's putting quite a bit of pressure on the automakers, who frankly had quite a lot of strife through late regulatory definition. So the zero emission vehicles mandate was really only finalised in November of last year to be effective in January of this year. The industry needs a longer planning horizon than that. Government's probably not been very fair, but the one thing that government did do was it did take some feedback from industry about how the mandate that was originally consulted upon the year before ought to be written, and actually they found an accommodation that works for the industry as well. So we've seen early adoption driven by financial incentives, and actually if you look at the vehicle segments, there's a bit of a story here. If you look at the D segment, which is basically larger passenger vehicles, the more expensive ones, actually last year electric vehicles outsold petrol and diesel vehicles 2-1. Hybrid vehicles sit in the middle. But if you look at the smaller end of the market, the kind of Ford Fiesta size that they no longer make, actually petrol cars outsold battery electric vehicles 2-1. It's the other way around. And that's a function of two things. Firstly, the availability of models. There are many more models available in the larger passenger car sizes because, frankly, they have a greater tolerance for higher price, and battery electric vehicles are more expensive today until the cost of the technology starts to come down as volume starts to grow. So it's more easy to sell into that higher price market and still actually have a reasonable return. And they're also typically the vehicles that are incentivized by company car schemes. If you look at the smaller end of the scale, you used to be able to buy a Ford Fiesta or equivalent for about £15,000 or £16,000 not very long ago, until very recently the cheapest small electric vehicle you could get was not far off £30,000 for something electric Corsa sized. So that's a major disincentive at that smaller end of the market for people to adopt, and frankly the car makers aren't making any money at that level either, so they don't want to make them, so they're only going to do it under duress or when the cost structure starts to change. So what we expected to see was some contraction of the market in the near term until costs start to come down and the vehicle makers can start to afford to make the smaller vehicles, which is where the mass market is. So that's essentially why the market has almost plateaued over the first few months of this year, but we do fully expect it to recover. The automakers have got no choice. They have to comply with the mandate, which means they're going to have to develop more models that will be more accessible, and they will be deploying technologies that are starting to reduce the cost. So we see this definitely as a transitional thing and not something that is going to upset the trajectory towards 2030. By which we think, according to our latest quarterly demand forecast, which we do every quarter and publish on our website, the UK will need about 91 gigawatt hours of batteries for electric vehicles in 2030. which is about 11 or 12% of the total European and UK demand combined.
I guess maybe just going to Graeme, just picking out a stat there around the mix of sales at the high value end of the market, which is obviously where sort of Goliath's targeting. So I suppose these sort of short-term blips haven't really had any impact on the conversations you're having with potential sponsors.
That's right. You know, the reality is that when you have a new technology, like solid-state batteries will be, you need to make sure that because it's manufactured at a relatively modest scale relative to the incumbent technology, so normal lithium-ion batteries in this case, that you launch that technology, you commercialize it into a sector that is more price tolerant. And for exactly the same reason, actually, that larger luxury vehicles are still outselling from an EV perspective. You know, that will be our initial launch market, and that is the market that most of the OEMs that we're talking about see solid-state batteries playing in, where you can emphasize the unique selling points of the technology, but not worry too much about being competitive with, let's say, commoditized battery alternatives.
Great. And Thomas, I don't know if there's anything you want to add to any of that around any impact on.
In terms of
Yeah. Well,
Yeah.
I guess just in terms of the sort of the market generally.
No, not too much about it. I think a key thing is I think when you look at some of the demand forecasts that the APC have come out with, which are personally, I'm not just saying that because Julian's here, I think really good demand forecasts. I think even globally we're still looking actually at a bit of an uptick, I think, from 2030. So it's not just here's a stall, and there's a correction back to where we were. The future forecast for electric vehicles is still ticking up. So that's something that's not going away.
Yeah.
It's worth recognising actually now. If you look at, despite the Prime Minister's shifting of one of the goalposts from 2030 to 2035, actually it was almost irrelevant because the zero emission vehicles mandate still ensured the same trajectory of electric vehicle deployment as you get out to 2030 and beyond. But we now have completely aligned targets effectively at the end point in 2035 across the UK and the EU 27. Okay. So that makes life a bit easier for the automakers.
Understood. That makes sense. And I guess one thing we're going to need if we're going to do all this is raw materials, and lots of them. I think it was touched on in one of the presentations earlier, but do you get the sense, maybe Graeme, that the raw material supply chain is sort of mature enough outside China to get Europe where it needs to get to?
I'd say not yet. I think the reality is that Chinese refiners and manufacturers of material are still globally dominant. This isn't a challenge just for this country, it is a global situation. But I would say that the big chemical companies in particular, as well as some innovative technology developers, are aware of the opportunity. It's clear that this is a growing market and that there are new materials that need to be developed and supplied as part of the new technologies that are being rolled out. And we're seeing international players step into those, often supported by some of the legislation changes that we were discussing earlier on in the morning.
And
China is a real risk in that, if you look at lithium, for example, around 90% of the world's battery grade lithium carbonate equivalent is processed one way or another in China. And many of the Chinese entities are highly vertically integrated from mine right the way through to refined battery input material, in some cases into batteries themselves. That's a very difficult place to come from because you've got no mark to market at any point. You've always got the opportunity to arbitrage with your own vertically integrated supply chain. The West is fighting back in different ways. If you look at the US, as was raised by one of the questions earlier on, through the US Inflation Reduction Act, you can only access many of those incentives as an at producer or an at retail level if you don't have materials that come from China, from key inputs. That's one way of doing it, but it's expensive and it's risky because you risk having differential pricing, which we're already starting to see for battery materials that are US IRA compliant and materials that are not. Europe and the UK have got a slightly different approach, and we're really focusing on building out those supply chains. So we've had a very strong focus through our programs in developing out materials that we can source from our own shores, like lithium, where we've got significant reserves in the UK actually, down in the southwest. And we've funded a number of projects from companies like Cornish Lithium and Imerys British Lithium, and a bit further north other companies that are focusing on refining of imported concentrates, specifically with a focus on building supply chain resilience and tilting away a little bit from a single country counterparty risk. And that is also the approach that's being taken by the European Union, and they've got things like the Critical Raw Materials Act coming into play as well, that's driving that. And there is money behind the clock as well to do that. UK's got a very strong focus on supply chain resilience, and actually Minister Ghani, who's recently moved from DBT into FCDO, has a very strong personal interest in critical minerals and building supply chain resilience, and sponsored a task force, which I was a member, to look at how we build those integrated and more resilient supply chains, and she's taken that portfolio with her into a new role. So I think we are doing the right things, but there is some intermediate risk where we are dependent on China, and I don't think you get there by playing King Canute, stopping it. You've actually got to try and build your own little supply chains that can help you tilt away, and that means looking right the way through to supply chain partnerships with other territories that do have the raw materials, and then allowing the UK to focus on the midstream processing, which is where we can really add a lot of value and where we have a lot of capability in our chemicals processing sector. Places like the Northeast and the Northwest are really good at chemicals processing, and that's an opportunity that we're going to try and exploit.
Okay. And is that sort of raw material availability something that comes across your door, I guess? Is it something that people focus on at that early stage of tech development?
Yeah, it's I say what we've seen, I think, since Faraday's, I mean, we've been investing in sort of early stage and sort of mid-stage research now since about 2017. And I'd say there's a massive change. I think if you go back to that point, I think people were worried about trying to make good materials, and that's all we really focus is small business starting up, or even larger businesses starting out in looking at batteries. Now everybody is going, no, I'm doing this because of critical mineral supplies, this reason, energy efficiency, and all the things that you would really hope that companies are focusing on. That's everyone's focus now, and it's something that we actively assess for when we sort of look to support companies. But I think there's a few other things to pick up on. So I think in the short term, yes, there's definitely this partnerships and this pulling through of critical minerals and the need for that. But it's also interesting because what you're generally seeing in the industry is a lot of pick and place technology. It's this works in China, we'll bring it through and set it up, because that's trusted processes, and to a certain extent that's what you need to do, because there are legislative deadlines. You need to get factories and processes that work, and you need to get them set up so that they're IRA compliant and all the rest of it to support the US and similar things for the EU as well. But in the same way that the gigafactories, and you might have heard because it's in popular news, like Tesla, revolutionising how you put together a battery cell. That's the same for pretty much all processes when you put together a battery. So if you look at cathode materials, so it's normally a blackish powder, various shades of black. Everything's black in batteries. It's the way that's made in China and globally is they're going to come with it. Pretty simple. It's take some things, mix them in a big reactor, filter it through a big filter, and then bake it and grind it a bit as well if you really want to. I mean, that's literally it. Very controlled, but those processes, first off, is batch processing. It's very inefficient. So some of the things we're starting to see come through, and a lot of the focus, I think, especially of people, looking maybe not at the first phase but second phase, is actually saying, well, we can't compete with Chinese manufacturing costs, but actually the way the market's going is we need to drive better efficiency of processing. And there's loads of efficiency gains to get, from making continuous flow processes, just having, constant, same as there is in every industry. If you automate it, if you make it continuous, you get the cost down. And through that's things that we're starting to see a really big push of people looking through that process manufacturing costs. How do you make these things smarter? Not just at putting cells and batteries together, but also the materials side and this sort of cost squeezing. There's so much room for cost squeezing throughout all of it. That's really important. And then the second point, I think, is worth saying that, you know, we export, I think it's about 80% of the cars we make. We also import a similar amount. Most of the raw materials that are going up in the UK are going to be in the shape of cars. Not immediately, but future. And that's the same for, I'd say, most of Europe. And what that means is there's a really, really big focus on how are we going to utilise that. I think some of the future sort of amount in terms of our critical minerals that could be supplied by recycling are actually really, really high when you look at maybe 10, 15 years. And I know that's long term, but in terms of thinking, in terms of long-term strategic supply, as soon as those things come online and become economically viable, then we've got a huge supply of minerals coming through. And I think that's one of the reasons why I think, you know, groups like Julian's and others are starting to really focus on what happens to end-of-life vehicles now. Because at the moment, you take end-of-life vehicles, you shred them, and then all of the something called black mass, so it's all of the sort of the shredded bits of the battery, has all of the materials in there that really high value, gets packaged up and shipped off to China where they refine it and then put it back into the batteries and then you buy them back in again. And that's what we definitely need to stop, because that's probably, in terms of the UK, got great lithium reserves. We've actually got some, you know, potential, you know, other really critical mineral reserves, and I think projects in Scotland. But there's going to be a massive amount coming out of recycled vehicles, and that's something we've got to keep an eye on as well.
That was a really good point, actually, and different car-producing nations around the world are in a very different position. So in the UK, as Thomas just said, we've got a positive mass balance of battery materials coming in through finished vehicles. So we will have a surplus of recyclate availability over time. If you look at Japan, for example, they're in almost diametrically opposite position because they make a lot of vehicles and export them, but they import virtually no vehicles. So they have very few raw materials themselves. They're importing all their raw materials and then they're exporting them in finished products. So they've got a huge negative mass balance. So these partnerships, you know, and we do have, you know, the critical minerals partnership with Japan and a number of other nations are going to be really important, looking at secondary materials as well as primary materials. And it also helps improve the sort of the life cycle impact of battery electric vehicles.
Good stuff, no, really interesting. And I think, obviously, the solid-state batteries is what focusing on today. I won't start with Graeme because I guess I know your view on this one. But in terms of sort of solid-state batteries, what are the benefits maybe, and do you think they can sort of drive adoption of EVs?
I remember, without giving too many trade secrets away, I remember a very difficult discussion back in my former employer about a new vehicle architecture and how on earth we were going to package a battery big enough to power the vehicle within the constraints of the vehicle, without making the floor too high or squashing people's head into the roof. And that was largely because you know, we're trying to package something that got cylindrical cells that were all stacked together in a pack. Each of those cylindrical cells was in a module, a small brick-like or shoebox-like module, sometimes a bit bigger. You distribute those in a pack which has got other containment around it as well, and you know, you're basically trying to fit big boxes into small spaces and they don't work. You've got some interesting things to do with lithium-ion batteries if you are talking about wet cells, conventional cells. Thomas will pontificate about this for a long time if we let him, but basically lithium-ion cells start to expand when you use them, and when they start to expand then they degrade and they fail. Right? So to stop them doing that, you have to contain them, you have to squash them. So cylinders do that nicely, they keep everything held together, but when you try and package them together you've got lots of gaps in between, so it's not very space efficient. You don't get much surface area for all the volume that you occupy, and then you've got to stick them all together and hold them in a big frame because they're not a structure in themselves. So what's called the cell to pack efficiency is quite poor. So that's the volume occupied by the pack compared to the volume of the cells themselves. And you add cost as well, and weight. When you start to go to big format prismatic cells or big pouch cells, you've got the opportunity to stack them all together, so you get better package efficiency, but you still got to squash them all to stop them expanding. And things like those pouch cells they need a lot of physical containment to stop them degrading. So you need strength. The advantage with solid state cells is that you don't need to contain them in the same way because they don't exhibit the same characteristics. So the opportunity afforded by solid state cells is disruptive on the way that you architect a vehicle platform, because you don't need to package so much stuff around the battery. You don't need to worry too much about crash protection from side impact, for example, because the batteries are inherently more safe. They've got no flammable electrolyte sat in the middle of it. You don't have to worry about putting a 6-inch nail through it, which is one of the common tests for batteries, right? You do that with a conventional lithium-ion cell, and it's quite entertaining. It's called a thermal event. But with solid-state cells, you don't have that issue. So you get much better cell-to-pack efficiency with solid-state cells, and that's where the opportunity comes in terms of volumetric efficiency and energy density and power density.
And do you think that's going to help drive adoption, Thomas?
Yeah, I'll help with that one. So yeah, I think we touched on this a little bit with talking about the different sort of classifications in terms of the automotive sector. I think there's sort of two time horizons on this. So one of which is that when you look at automakers designing, I'd say very much in the large segment, and we're talking very large cars, very expensive cars, where customers have a certain performance requirement. Which is, I want to be able to drive very, very, very long ranges. I want the performance to be really, really high, and I'm not accepting less. And the automakers are very, very aware of that. You can't take a Range Rover and say yes, you can drive that, but only 30 miles at a time. And actually, we're going to step off the acceleration of your new Ferrari, electric Ferrari, because actually, we're trying to protect the battery a bit, so we're going to back off the performance. No, that doesn't sell. So when you're looking at those cars, those are, I think Graeme has mentioned, they are the sort of the segments that are looking really at the sort of next generation of batteries, the really high performance batteries, because they will sell cars, they can't afford not to, but what they have to do is either go incredibly intensive on that pack engineering that Julian was talking about, trying to squeeze every last little bit of available space, every little bit of mass out. Because the batteries, the actual cells they can buy are probably the same as everybody else's. They're not massively different. They really are, all shades of the same sort of performance. It's all on how they're assembling and packing those in. What solid-state batteries will enable them to do, though, is, as you say, strip a load of that out and allow them to offer that performance that is expected of the customers of the premium price tag. It's one of the reasons why, for sort of the next, for that introduction piece, it makes sense both from a volume perspective, but also from a meets customer demand perspective. So very much on those, I would say hard to electrify. And the reason I say hard to electrify is they will be, but it's hard to electrify and keep the performance that's expected by the customers. And I think that's the real bit where it's going to drive it. As you then walk out in time, and I think Julian's touched on solid-state batteries, and the reason that people have been so excited about them for so long is because yes, you've got the inherent safety, so you can squeeze things out of the performance, which is great. Because I think I always personally say no car that is sold with a battery in it is sold not safe. They're all designed to be safe. What the extra safety, inherent safety, allows you to do is design out all of more controls, so you get, you don't need to control the heat as much, you can sort of push it a little bit more, or the software limits that, at the moment when you charge your car up to 100%, it's not charged up to 100%, it's limited. When you put your 4 down, you're not getting all of the performance out, it's all limited. All of those things can be rolled back so you can get more performance. But it also comes back to that manufacturing piece, which is really, really important, and I think where, especially in the UK and in Europe, etc., we're used to making technology efficient and making things really well. And I think that's a really big point. Once you get away from the conventional battery manufacturing process, which no matter what way you're going to make a solid-state battery, it's always going to be slightly different. It might be a little bit different depending on the route you go. It might be able to cut out certain parts of that process, maybe reduce certain times. Or if you're going for really out there solid-state battery technology, you could throw the whole process in the bin and start again. But what that does is it gets you off the current track and gets you onto things where you can start having these things in smaller footprints. You can have much less capex expenditure into your factories, and that's where, when you look at the cost point of solid-state batteries, that's why they're always coming out, far into the future, really, really low, and that's the point at which then they can appeal to mass market. It's sort of that longer-term duration.
There's another factor actually that's often overlooked. If you look at the technology that is the internal combustion engine, it's pretty much ubiquitous. It'll work in very low temperatures, very high temperatures, high duty cycles, low duty cycles. Conventional lithium-ion batteries have got a bit of a problem in that they don't like being very cold and they don't like being very hot. And one of the advantages of solid-state batteries is they've got a much wider temperature capability. You think about signing off cars that are going to work in Siberia, maybe not at the moment, but they've got to work in or even Canada, they've got to work in -40. Batteries don't work at -40. You have to keep them warm, so you've got to keep them plugged in. If you go to the Middle East, they've got to work in at least +40. Some cases the sign-off is +45 or +50 C. That's that kind of temperature. You haven't got much leeway before you start to get to thermal runaway position for conventional lithium-ion batteries. So it's not so easy to ubiquitously deploy conventional lithium-ion technology in all operating environments. And this is where solid-state technology can extend the operating capability of vehicles, electric vehicles, in some of those more extreme markets. Yeah, so I think, and people will pay for that. So it's a great premium opportunity.
Graeme, just I guess earlier on it was mentioned, a few of the competitors are well funded by OEMs, and I think we've seen Nissan mention solid-state batteries more recently. So, in the conversations you're having with the OEMs, are you seeing them? Is sentiment improving? I suppose that they can realise a lot of these benefits, as someone mentioned earlier. Solid-state has been around for a long time as a potential technology. So, are you sensing that we're much closer?
Yeah, absolutely. I think every global OEM and Tier 1 in this industry has got solid-state on their roadmap, and whether they have an in-house program in order to deliver that, or more often they're looking for collaboration opportunities, everybody realizes that actually this is the direction of travel, and they have to have a plan in place in order to make it happen. And I think perhaps the other point that builds on what Thomas and Julian were saying earlier about recycling of batteries being really important. Solid-state batteries lend themselves to be recycled in a much more straightforward manner. And in fact, as part of our current Faraday Battery Challenge program, there is a study, an LCA study being done by HSSMI, one of the collaborators, working through that whole recycling argument. And it's very clear that if you've got a simpler all-solid battery, it's easier in order to extract all of those minerals, those critical minerals you want to put back into the supply chain, if you've got a solid-state construction relative to one that's got a polymer separator in, a toxic, potentially flammable liquid electrolyte. You don't have those worries in solid state.
Okay. Started to get conscious of time, but I think we've got a little while left. So last one, I guess, just thinking about, we've had some high-profile and lower-profile battery companies that haven't worked in the UK recently. So maybe from the sort of the early stage point of view, what are the unique challenges in terms of making a successful battery company?
Yeah, in terms of the stage, so yes, I mean we've, just to put in context, so we as a challenge, we supported about 150 organisations today, about 118 million worth of grants. Those companies have gone on to raise, about 780 million so far. We're actually doing quite well growing companies, I'd say, at an early stage in the UK. A study I think we did last year pretty much showed we've got what's sort of the fourth highest enterprise value in Europe. We're really good at growing companies. I'd say what is a struggle for us and also other people is it's that the scale up stage. It's the stage that Ilika is really pushing through right now. It's getting that technology from I have a great idea through and staying on that track up to then be able to get to mass market. And that is not a battery problem. it's a hard tech problem. It's a I don't just make software problem. And it's because of, I don't need to say people in this room, but it's because it requires quite a lot of patient capital to sit and work through and create prototypes and get out there. And that's the same for batteries. It's same for any sort of hard tech physical products that are made. I think what the unique, I'll start with the challenges and then get on to some positives actually. But I think the challenges of batteries is the rate of change. So it's the rate of the speed and the fact that everything is standing up really quickly. And what we're hearing from companies across the board, and it's great to hear that Ilika are in the door talking to OEMs around solid-state battery technology, is that the barrier to entry to get into an OEM or into a gigafactory's R&D department, which is where everyone starts. You don't start at the purchasing department when you're scaling up new battery technology. You start talking to the R&D people. The barrier to entry used to be, I've got some technology, can you test it for me? That's going back maybe 7-8 years ago. Now to even get to that point, to get into the front door, if you have a material, so a single pellet cell, you need to be able to provide that material. You also need to provide the data sheets of what that looks like in a representative battery. You also need to know what that battery means at the module and pack level in terms of your value proposition, and also what it means at a vehicle level as a value proposition, and you have to have that ready and waiting to give to the R&D departments, because they've got everybody after them. They've got, they really need to know that they can invest their time in talking to your company. So once you're in the door and you've got that position, that's really good. And then the problem is it's a nice problem to have, but it's ramp up. Once you're through the door and you're starting to click through, we've got examples of companies talking in the UK that they've gone from, oh yes, can I have a few hundred grams of material, please? The next month it's, can I have 10 kilos, please? And then in 6 months' time it's, right, can I please have 500 kilos? For a company that's making 100 grams to be asked in 6 months, can you supply half a ton of material? That's quite a significant ramp up. And that's why, in the UK, that's why we built things like the UK BIC, who I know we're collaborating with, it's that battery industrialization centre, because you can go and, when you can't wait for a whole battery line to go up there to prove your stuff at that sort of scale, so you can go and use the open access facilities. We're also doing a similar thing up in the northeast with a sort of a material scale-up facility that we're investing in building it now and building all that sort of capability. And that's why it's really critical. We've got quite a good growing ecosystem in the UK of that open access facilities, is because of that ramp-up scale that you need to hit to sort of keep on track. The positive, and I appreciate on time, the positive is unlike quite a lot of hard tech, there is such a legislative deadline and there's such pressures on the OEMs to get the best technology through, that if you can hit all that and you've got a really good technology, and the technology allows you to get that next step, then you're off. Yeah, you just need to get through the door.
And is that similar, I guess, when you're moving into industrialisation, to those challenges?
Yeah, it is. The big challenge is the scale of the capital costs to industrialise, and you've got to make sure that what you're industrialising is contemporary and it's competitive. Frankly, the margins on conventional lithium-ion batteries, particularly LFP cells, that largely produced in China today, is wafer thin. So it's about volume and it's about getting capital cost efficiency. And even at that level, you're still looking at investing, at least 100 million per gigawatt hour pounds for industrialisation. That's just for cell assembly, right? When you start to get at smaller scale and more esoteric technologies, then actually you start to spend a lot more than 100 million per gigawatt hour. And that's why you see most gigafactories being built in the Western world are, many billions, somewhere between 2 and 4 or 5 billion pounds or dollars, to industrialise at reasonable scale. The bigger challenge is the link with the vehicle development timeline, because frankly the vehicles that you'll be driving in 2030, you'll buy in 2029, are already on the concept drawing board today. It takes about 5 years to go through a full new architecture development. And you start with target cascade, getting down to component level specification, then you've got to go through a full validation process. And as much as we try and do more and more of that using virtual techniques in the simulated domain, you still need some physical testing, particularly with these nascent technologies. And that means you've got to provide physical samples that are production representative at a relatively early stage. So, the challenge for battery companies, and this is why we're trying to bridge that gap with government funding, and this is not unique to the UK, the EU are doing it as well with their IPCEI schemes, and the US is doing it too, is to make sure that you can support the production of production-like samples at an early stage, and then you have to sit there and wait for them to go through the combined vehicle development testing regimes before you can then get to the point where you're commercially sourced and you have a strike price. So you have to be patient, and if you try and rush it, if you try and grow too fast without getting all of those samples out at the right time, then you run the risk of running out of cash. So you've got to make sure that you've got deep pockets when you start this, but if you bold and you hold your nerve and the fundamental technology is basically good, there is a ready market at the premium end, because it's that leading edge where the margins exist, not in the mass market.
And then, Graeme, I guess finally, which sort of challenges are you facing most at the moment?
Well, I think the key to Ilika's success, where perhaps other battery companies may not have covered themselves in glory, is to have a risk-managed approach to the challenges that Thomas and Julian have just outlined. In that, we say that we will develop our batteries and get them to A sample. So this is the language, the vocabulary of the automotive industry, where an A sample is a cell that has the function that you need to power your application. A B sample is then a battery that has the same specification but is actually made on a piece of equipment which is industrially relevant. So you could transfer that piece of equipment into a larger scale facility. And then a C sample is actually where you start to make volume production of cells on that piece of equipment. So the idea at Ilika is that we get to A sample, and that's enough so that we can engage in an RFQ process, a request for quotation, from an OEM. They can tell us what they like about what we've made and what we need to improve, and actually we can get qualified for the rest of the commercial procurement process at that point. But then we partner for B samples and C samples and work with the UK Battery Industrialisation Centre and also Tier 1 manufacturers themselves, in order to avoid the requirement on Ilika to actually deploy those hundreds of millions of capital that's required, because actually we believe that through partnership we can get a more efficient commercialization journey for both Ilika as a developer and also for the Tier 1 and OEM as manufacturers.
And that's exactly why UK BIC was paid for by government.
There you go.
Great. Thanks. I think we are up against time now, but thank you, Thomas, Julian and Graeme. Really interesting discussion, and we'll hand it over. I think to Jason.